Yeah. Discord. Don't have any after this. Sweet. All right, everybody. Thank you all for coming. This will be the first lesson for the learning based project and just kind of an intro to web dev in general. So yeah, today will just be some of the basic introductions to TypeScript, which is the variant of JavaScript that we use. So yeah, you can start. Yeah, so I'm Xavier. Basically, how the structure of this is going to work is we're going to do a quick little lesson where we talk about some of the concepts, and then at the end, Alex here is going to do a demo, do some live coding. So hopefully that goes well. Do some live coding with the concepts that we've been talking about. Yeah, so today we're going to be talking about TypeScript, GitHub, and then doing that demo. So first, what is Git and GitHub? You might have heard this before, maybe not. Starting out, what is Git, right? Git is essentially it's a version control system. What does that mean? Well, as you're working on a coding project, right, you make a lot of changes and sometimes you break stuff. When you break stuff, it's hard to just undo, and you might lose your working code, and you don't want that to happen. So what Git does is it's a version control system, which allows you to, if you broke some code, you can go back to a known point in the code where you know it works, right? That's essentially the use of it. There's a couple other uses in here. Going over some of the terms here, it keeps records of previous versions, and it also allows several people to work concurrently. So if you're working on a team, maybe there's, a central place where the code lives, and you need a bunch of people to all contribute to that code. How do you do that? Well, Git is great for that, and we'll talk in the future a little bit about how you can kind of do that. We'll probably have to do a live demo at some point. But we'll be working with it in your teams on the learning-based projects. So definitely get familiar with it. If you've read the onboarding, which you all should have read the onboarding, right? You already have a little bit of background knowledge on this. Just going through what's on the slide here. Stores code in a repository, and that's just a folder that has all the code. Everyone has a copy of this repository, and then you work on your own like branch, as it's called. So essentially what happens is with GitHub, you have a main branch, and that's just the working version. You know that version of the code is good. Then if you imagine like a tree, you'll like branch off of it, create a new tree branch here, make your change. Once you know your change is okay, you'll put it back into the main branch, right? That's at a high level how Git works. Yeah. So then what is GitHub? Well, GitHub is not the same as Git. Git is the version control system that enables for collaboration, but then you need a place to actually store your code, right? You don't want to just put it on everyone's or you don't want to just store it on your own computer. How are other people going to get access to it? So GitHub lets you store your code on their servers, and then everyone can pull that code and work on it on their own laptops, right? So like instead of having to say, hey, teammate, can you send me your code and then we can start working on the Git stuff? You can say, oh, I have this GitHub repo. I'm gonna just pull from that, and now I have the latest working version of the code. On top of that, they offer a couple of nice things for collaborating with teams. The first being pull requests. What is a pull request? A pull request is where you're saying, okay, I've got this feature here on this separate branch. Now I want to put it back into the main branch. So before I do that, can someone else on my team look at this code, make sure it's all good, make sure it works. And then after they do, and after it's approved, then you merge that branch into main. Does that make sense? I know it's like weird and I'm trying to show the branches with my hands. Does that all make sense? Okay, cool. Has anyone worked with Git before? Kind of, some people. Okay. You get a lot of experience. It's very, very widely used in the industry. So getting this experience now as freshmen or sophomores or whatever you are is super valuable. And then you also have issues, and this is the main way that you can use. This is something you can use to track what needs to get done in your project. This is how we'll manage tasks in our teams. So we'll have issues in GitHub, which is like, maybe you have a bug in the code, and you'll have an issue in GitHub there that's like, fix this bug. Or you'll have a feature that you need to do, and you'll have a issue that's like, build this feature. Yeah, so that's Git and GitHub at a very, very high level. We probably should at some point do a demo. Yeah. Okay, cool. So that's Git and GitHub. Moving on. TypeScript. What is TypeScript? Has anyone heard of TypeScript? Heard of JavaScript? See, most people have heard of JavaScript. JavaScript is essentially, it allows interactivity in the web, right? So before you had JavaScript, you just had a bunch of static pages and you just clicked buttons and filled in forms and clicked more buttons. But now when JavaScript was introduced, you could add stuff to the page dynamically, get an animation to play on the page, all this cool stuff that really makes the web feel more interactive. And we use JavaScript a lot at Hack for Impact. But a core issue with JavaScript is that there's no type safety. If you guys all work in Java, or you've used C or C++ or Java before, you'll know when you pass stuff around to functions, you have to say like what type something is, right? You have to say this is going to be an integer, or this, or do you have to do that in Java? Yeah. Okay. You have to say this is going to be a number, or this is going to be a string, or whatever it is. JavaScript doesn't have that. So you could have something that's expecting to have a string, but then you give it a number and who knows what happens, right? So TypeScript comes in and it adds types to JavaScript. I wonder how they got the name, right? It's widely become an industry standard. So these days, if you're working with the web, you'll probably be working with TypeScript. And it doesn't actually run on the browser. So this is also an important thing to make note of. When you have TypeScript code, what's called this program called the TypeScript compiler will turn that TypeScript into JavaScript so that you can actually run the code on the browser. Does that make sense? Just checking in. Have we lost anyone yet? Thank you. So let's do a quick syntax overview. This might look a little familiar, especially those of you who have done Java. You have to define a function, you'll write the function keyword. All right. You'll define a function using the function keyword. Then right after that, you'll give it a name. Then you'll declare the arguments and the type of the arguments. And that's the format of name, type. And then you can declare what the return type of the function is going to be by doing all that function stuff, then a colon, and then the type that the function should return. Then you have the function body, and that's just normal code. You've seen that before. So let's do a quick kind of side-by-side comparison of Java and TypeScript. As you can see, it's pretty similar, right? You don't have to do any of that public static nonsense, which is great. But it's pretty much the same. Only difference is you use this function keyword to define your function, and whereas in Java, the return type is right here. In TypeScript, the return type comes after you define the function. Any questions about that? It's all looking pretty familiar, pretty easy to grasp. Okay, good. So let's talk about declaring variables in TypeScript. There are two ways that you need to know how to declare a variable. The first way is let. So if we go back here, you'll see in this example function, we're declaring a variable with let rv, giving it a type, and then giving it an initial value, right? The important thing to know about let is you can change the variable. Or not change, you can reassign the variable, I'll say. So you can see here in this for loop body, we're doing a plus equals a. And so what we're doing is for each iteration in this loop, we're adding another a, right? So if, just by looking at this, you can see the code, you pass in a number to this function, and then whatever number you pass, it'll return you that many a's. So the important thing here is that with let, you can reassign a variable, right? Does that make sense what reassigning a variable is? Okay, cool. Const is, let's say a variable shouldn't ever change, right? You can declare it as a constant or const, and then you'll get an error whenever you try and reassign it. So as you can see here in this loop, when I'm trying to reassign RV to be, to have another A, it's like, whoa, you can't do that. This is a constant. That value can't change. It's got to be the same. And that's useful for, if you have some data that will never change, it makes it a little bit faster, as opposed to having to make sure it doesn't change, right? It it's a speed increase.
It's also nice for knowing later on in your code that you'll get an error when you're trying to mutate a variable that you shouldn't be trying to mutate.
Yeah, definitely. I totally didn't even think about that. Does that make sense? It's like if you know that you shouldn't ever be changing this variable, you don't want a developer to come in and accidentally change it. So that's why you would declare it with const as opposed to let, because then it'll throw an error instead of just letting them do it and then messing up whenever your code is live. How are we feeling about let versus const? Up, down, middle? Awesome. All right, so now let's talk about types in TypeScript. The first thing you need to know is what an interface is. Interfaces let you declare your own custom data types or shapes of data. And this is used for type checking, right? So if you think about it like Java, it's kind of like a class, right? You can define data that should be in this type. So in this case, in this example here, we have this person interface, and the data that it should have is a name, an age, and a middle name. And you might notice this question mark on the middle age right here, middle name right here. That's just signifying that that property is optional. So as you can see in later on in this example, we have person 1, and that's defining its name as Alex and the age is 22, but no middle name. Totally fine, all good. And then for person 2, we're saying the name is Xavier, the age is 21, and the middle name is Jackson. Also perfectly good. So that question mark is just saying that's an optional field. And we have documentation linked here in the slides. I definitely recommend reading on it. They're going to do a much better job of explaining it more thoroughly than I can in this amount of time we have. So I definitely recommend going to that and taking a look at that. Should we send that out to the Discord after the lesson? Okay, sweet. And then also when working with JavaScript, you'll hear a lot about these things called objects. An object is just an instance of an interface, right? So the interface here, the type would be person, and then person 1 and 2 are both objects. Okay, so yeah, it's just an instance of an interface. Does that make sense? I know it's a lot of words and stuff like that, but feeling good about that?
Yeah, it's just like an instance of a class of Java.
Right, yeah, that's a perfect analogy. Yeah. And then let's take a look here at this bottom example. TypeScript is awesome because look, here I'm trying to assign name to 2, which is a number and not a string. And it's yelling at me. It's saying type number is not assignable to type string. And that's really useful because, you know, maybe you have some data coming in and you don't know that it's exactly going to be right. TypeScript will throw an error for you and say, hey, you can't do this. Make sure your data is right, which is super nice and reduces bugs a lot. Cool. Any questions about that? Any questions about anything we've covered so far? Awesome. Now let's talk about how you can compile and run JavaScript. So if you've read the onboarding, which again, you should have, please read the onboarding. You'll know that we use Node.js to run our projects, but you might not be too clear on what Node.js actually is. Node.js is a program that lets you run JavaScript on your computer. Before Node.js, you could only run JavaScript in the browser, and then Node.js came along and said, actually, we want you to be able to run this on your computer just like any other programming language, right? Do you guys all understand the difference between running it on your computer and running it in the browser? Okay. Oh, no. Okay. So before, anytime you wanted to run some JavaScript, you would have to put it on a page on a website, and then the website would have to load that JavaScript and it would run it there, right? And that you know, that's fine, but JavaScript is a cool language. People wanted to run it for, you know, other stuff like how you guys build your Java labs. They wanted to be able to do that kind of stuff with JavaScript and actually run it on their computer instead of in the browser. Is that cleared up? It's kind of hard to grasp that difference. So if there's any confusion, just let me know and ask questions.
Do you guys use the Hydra machines for your labs? Okay, so think about trying to run JavaScript on the Hydra machine versus trying to run it. Like there's no Safari, there's no Google Chrome on the Hydra, so you wouldn't be able to run any JavaScript with there. Whereas with Node.js, you actually can.
Yeah. Pound you for that one. That one's sweet. Yeah. And then earlier we talked about how you can't actually just run TypeScript. You have to run JavaScript. So in order to run your TypeScript, you have to do what we have on the slide here. So first, you'll install TypeScript. And this is, you won't have to do this for the projects you work on with us. This is more like if you just want to, create some TypeScript projects on your own to play around with it. So the first thing you'll do after you've installed Node and npm is do npm install, that -g just means globally, TypeScript. So that's just installing the TypeScript package, the TypeScript program onto your machine so that you can use it later. Then after you've written a TypeScript file, so here we've got the example.ts file, TS is for TypeScript. We have that file, now we want to actually run it. First, what we have to do is we have to run npx, which is just how you run stuff through Node. TSC, which is a TypeScript compiler. And then the files you want to compile into JavaScript, so example.ts. What that will do, you can see that right here, is that'll spit out a file called example.js instead of example.ts. Example.js is just normal JavaScript, so you can then just run it how you would run any other JavaScript file with Node using Node and the file name. Does that make sense how you would run TypeScript stuff on your computers?
We'll see it in just a second.
Yeah. Yeah. Sweet. Any questions about any of this? Anything we've covered? Okay. All right. So this one's a little bit more complicated. Async and await. When running TypeScript code, some tasks or functions don't return instantly, right? And you need to make sure you wait for these functions to return in order to continue your program. Like, what if I had a function that doesn't return instantly? I call it and then I run the next line of code, assuming that I have the return of that function. Well, it wouldn't work, right? Because we don't have it yet. We have to wait on it. So what you can do is use async and await. You can define a function as asynchronous using the async keyword. And we'll look at an example in the next slide. And then whenever you want to make sure you wait for a function to finish executing, you use the await keyword next to that function. So an example of this, right, would be like, let's say you have a weather app, right? You're trying to build a weather app for the browser, and you need to actually get the weather data from somewhere, right? So you call out to another website and you're like, hey, give me this weather data back. Well, if you've ever visited a website before, you know that websites don't instantaneously load. It takes a minute for them to load, right? So what you need to do is make sure you wait for that website to load and give you your data back, and then you can actually use it and display it in your application or whatever you want to do with it, right? Is there a good analogy between Java that they would know?
Not without multi-threading.
That's a good point.
Like in other programming languages like task, JavaScript will always wait for one line of code to execute before going. If there is something that takes a long time, like going and getting all this weather data, if you don't use async and await, you'll have a line of code to go get weather data. And while it's going and getting that, it will keep running and keep executing the next line of code. So if you need to use that weather data for something else later on, it'll work. So you use async and await to say, hold on, wait until we get this weather data back, and then we can keep running it.
Yeah, so let's look at a quick example of that. So this is how you would define an asynchronous function. As you can see, it's pretty similar. Two couple confusing things. First, you got this async keyword that's just telling JavaScript or TypeScript that this is going to be an asynchronous function. And then if you look at this return type, you'll see this promise thing and then string, right? What does that mean? Well, what this is saying is that this function, even though it's not going to happen right away, it's promising that at some point it's going to return a string. Okay, so at some point this function is going to return a string, but it's not going to be instantaneous. Does that make sense? That promise keyword is a little weird, so I want to just do a quick check-in and make sure everyone's on the same page about what that means. Cool.
This is stuff you get used to.
Yeah,
it's a little unintuitive.
Yeah. And then in the function body itself, you can see we have this function call to get data from database. So that's just saying like, let me get some data from a database, but we're not going to get it right away. Like Andrew said, we need to wait on it to return before we can return the result. So we use the await keyword here to say, okay, pause execution at this line. Don't keep executing the function until after this get data from database function returns. Then after that, you can go ahead and return the result. We also have this try catch thing. Have you guys seen try catch before in Java? You have? Cool, perfect. So yeah, you'll know that that's just saying, try this code block in here. If it errors, catch that error. And then in this case, we're console.errors, which is just basically printing out an error to the console and say error, and then whatever the error was. And then to make sure TypeScript is happy, we still have to return a string. So we just return an empty string. Okay. Does this code example make sense? Cool. Any questions about any of that? Because we're about to do the demo. All right. Good luck.
All right, so for the code demo. Cool, so are any of you guys familiar with the cat program and what it does on the terminal? So all the cat program does is print out the text contents of the file. So yes. So all cat did is just print out this file that's here. So to emulate that, all we're going to do is read in the contents of a file and print it back out. So to do that, we're just going to create a new file. We're going to call it cat.ts. .ts is the file extension for TypeScript. So .java is Java, or I think it's .java. But yeah, so first things first, we want to make sure that our build system is up and working so that we can actually compile and actually run this code. So I'll just go ahead. Let's see. Hello world. We'll just call the main function. And then let's see. So first we'll make sure TypeScript is installed. It's up and running. So cool. So we can go ahead and compile this. So TypeScript compiler, cat.ts, it'll compile. Cool. So now we can actually see that we've got both cat.ts and cat.js. So we can go ahead and run cat.js and we get our hello world. So now we know that our build system is up and running. And so I cannot see this through the recording. Cool. Yeah, that's actually true. Sweet, thank you for that, actually. Cool, so now what we want to do is read in the contents of a file, the text contents, and then store that somewhere and then print it out. So to do that, we're going to create an interface, and we're going to call that a cat file. So this interface, we're going to give it a name, which is going to be a string. We're going to give it the content of the file, which is also just a string. And then we're going to give it a length, which is just a number. Number is TypeScript integer type. It's also floating point. It kind of encapsulates it. So what we want to do is actually read in the contents of this file. So we're going to make a function. We're going to call it read in the file. It'll take in a file name. That'll be a string. And it'll return a cat file. So first thing, if you saw that error, it's just complaining that we're not actually returning anything yet. But we're going to define a buffer, so we're going to read in the file contents to. And before we read anything in, we actually need to import a library. So we're going to import star as fs from fs. And this is just the way that you import things into a TypeScript file. All the star means is import anything that is exported from this file system or fs library. And then you can use this fs keyword to invoke the function. So what that means is that we can say let buffer equals fs.read file sync, and we'll just pass it the file name, right? And so now we have read in the file contents to this buffer, and then we can create a cat file. So we can let new file equals, or let new file cat file, and then we can just define some of these properties. So the name is just the file name that we passed in. The content is going to be buffer. But actually, if you see this, I didn't define a type on the buffer, but it's actually a type buffer. And this content takes a string. So we actually need to invoke this toString method. And you'll actually get used to this in TypeScript, where you'll have to search through documentation to see how to convert things to compatible types. It's a little bit annoying, but it's worth it. And then with the length, we'll just do buffer dot length. And then we can return the new file. And as you see, we get no errors, but we actually want to use this function. So we'll say let sync file. We'll say read in file, and we'll just print out this file. So we'll say cat.ts. Sweet. And then we'll output the file.content. Right, and then make sure this is called. Cool. So if this is right, what this should do is read in the file contents from this read in file to a buffer. We then put that buffer into our interface along with some other corresponding data. And then we, in our main function, call this read in file and then print it. Console.log is just the standard IO. I think it's, what is it? System dot whatever it is in Java. So it's the same thing. So if we go over here, we can compile again with no errors, and then we can run. And there we go. We can now print out the contents of this file. Now, we did this, and if you notice, we use this sync right here, which means it reads it in synchronously. However, what we can do is make this an asynchronous function, just to demonstrate what that's like. So if we make this an async function, well, we're actually going to need to import a new library. Import promises as AFS from FS, which then we can then use here. AFS is just asynchronous file system, is what I'm abbreviating that to. And then this is refile. Now, if you see this error, it's saying that the type of promise buffer is not equivalent to the type buffer that I've declared. And what this means is that because this is an asynchronous function, remember, it's returning a promise. And so what we want to do is use this await keyword. And that way we await on it. And you see we get another error saying that, which you can't see because it's cut off, but it's saying that we can't use await inside of a non-asynchronous function. So what we want to do is make this an asynchronous function. And then you see we get another error, which, just to show you, is saying that we're not returning a promise from an asynchronous function. Now, again, what this is saying is that we're promising that in the future, we're going to return a cat file. And now actually this should work. This is all we need to do, except when we invoke it, we need to do let async file equals read in file, or I'll just do read in file async. Then we'll do cat.ts. Sweet. And then we'll do oh yeah, so we get this error saying that this property content doesn't exist. And because I didn't declare a type on this, it inferred that we're returning the return type of the read in file async, which is a promise. And the promise does not contain the actual fields of the interface because it has not been resolved yet, but you don't need to worry about that. All that means is that we need to use the await keyword, which then means that we have to use this async keyword on the main function. So you can see how this cascades up your function called chain. So if you're 4 or 5 levels deep of functions and all of a sudden you have to use an await, you can get into trouble as they stack up. It gets annoying, but it's something you kind of just end up dealing with. But as you can see, we should now be able to actually compile this. So npx. Actually, if I saved it, I don't know if I saved it. So npx tsc cat.ts. Sweet, it compiles, and then node cat.js. And sweet, now it works. It runs. And that's just a demonstration of how an asynchronous function call works. But yeah, was there anything you want to go over GitHub? Also, are there any questions on that? That was kind of quick. Does that kind of make sense how this kind of thing works? How an asynchronous function, you have to return a promise, and then you kind of have to make sure that you wait on that promise before you can call the data. Which two lines? What do you mean? Oh yeah. So what? Oh yeah. So what he wants me to say is that there's a difference between these two lines. What he's saying is that this line right here, the read-in file, resolves instantaneously because we use this read file sync. And because it's synchronous, we don't have to make sure that we wait because it already makes sure that we don't have to wait. Whereas with this await, this is asynchronous. So if we were to continue on, TypeScript is actually nice in that it'll throw an error and won't let you do this. But in JavaScript, it will just let you continue, and then you'll get some undefined behavior because you haven't defined what async file is when you're trying to print it out, if that makes any sense. So you kind of can end up doing this before you actually finish that. Is in a basic sense what it is. Sorry.
Also, it's hard for us to not use words we know. Are there any words that we set up
Yes,
here that you guys don't know what mean? Because we'll be happy to explain those right now.
Yeah.
Yeah, just call it out.
Yeah.
Anything?
Yeah, no, that part's pretty confusing. So can I make this bigger? Okay, so if you see at the top, this import star. So if you think of this FS that's in the quotes, that's just a library. So have you guys used importing files in Java yet? Okay, cool. So it's essentially the same thing. But in JavaScript, what we do is we export and then we import. So this FS library has a number of functions, including this read file and read file sync that have been exported from that library. And what we're doing here is we're saying import all of these exported functions as FS. And this FS, I don't know the exact details, you might be able to go into it, but it allows you to invoke the exported functions through that. So we imported this read file sync with this star, and then we can call it using this FS keyword.
Yeah, so you can think of it like bring in everything. Let's pretend you have a file, a JavaScript file called FS, right? It's saying bring all the code in from that FS file and then set it to a variable called FS, right? So then whenever we call those functions, we're just pretending that we have that variable named FS, and then that variable FS has a method on it or a function on it called read file sync. Does that explain your question?
Yeah. And this promises one is doing the exact same thing, except what you can picture is that there's this FS library and then slash promises. So you can see it even autofills. So it's just taking this promises and it's putting in this AFS variable, which I'm just saying is asynchronous file system because I'm just abbreviating it. And then it's importing it from this FS slash promises portion of the library, if that clears it up. Does that make sense? A little more sense at least.
Sweet. Anything else in the demo or otherwise that was confusing for anyone? Don't be afraid to speak up. We want to know. We want to make sure everyone's on the same page here. Yeah.
Yeah, so I think if I pull up VS Code, let's just open it. Oh, Java.
What was your question again? Sorry. It won't run it for you. It will, and we'll talk about this more at the stand-up meetings we do with our individual teams about how to run your projects, but you can still code in it. And then, you see down here, he's got this area where you can put in commands. You can just type in that node command you saw him do earlier and run your code like that. Does that make sense? Okay. Fine there. Don't know if that's fine.
Yeah, so what Visual Studio Code does is it uses plugins to actually run the code. So Visual Studio Code has a Java plugin that can compile and run Java code. Whereas if you're on the Hydras, what do you use? Java C? Is that what? It's what? Oh, you do C++. Okay, so it's just G++ for that, I guess. Yeah, okay. So like Visual Studio Code also has C++ extensions, which will just use a C++ compiler to run C++, basically.
Yeah. Any other questions?
Oh yeah, so when we think of a buffer, yes, right. You guys might not be too familiar with this yet.
C-brain.
Seriously. So what we use a buffer for is we essentially are saying this is where we just want to store the contents of this file. So think of, I could have named this anything, so I could have said content, but it's still of type buffer. How to explain to that memory application?
I've got a good
Yeah, go
analogy.
for it.
This one helped me. Okay. Imagine this buffer variable is like a toilet. Okay. When you have your toilet and you put stuff in it, stuff goes in it, I'll say. It's just sitting in there, right? Waiting to be flushed, right? When you flush it, that's when you're actually doing stuff. So in this case, you can think of flushing it as actually using this .toString method. That's saying, okay, get everything into the toilet. Once everything's in the toilet, flush it into a string. Does that help? I learned that one when I was learning C. So who asked that question? Does that help? Yeah.
You're gonna essentially think of it as somewhere to store the data before you use it. So you're storing it there while you're reading it in, and then you use it afterwards. Good question.
Any other questions about anything? Async away, TypeScript, Git, interfaces.
We can do a Git demo after this.
How much time? Well, we don't really have one.
I was just gonna make a repo, and pull it down and take a break.
Okay.
If that's allowed, I don't know.
Sorry? Yeah, sure. Do you want to pull that one up? Do you have the?
I mean, I got on the hack for impact, GitHub it forever.
Yeah.
Let's see.
While he's doing that, don't hesitate. Questions. I want questions.
What's my GitHub notes? Go to where's the hack for impact?
So this is our GitHub. Should all be in the GitHub right now. You all have GitHub accounts, right? Yeah. I've added you all to the organization. I hope. If I haven't, come talk to me. You'll be able to see all of these repositories or all of these code bases, code stored places. In this GitHub here, where it's put it up, and then
Down. I was looking for CCH.
So this is a project we did last year. What you can do if you actually want to get this code onto your machine, you just copy that.
Yeah.
And then there's a couple commands you can do. And again, it's in the article. So if you haven't read that, do that.
Yeah. So this is cloning. So it's essentially saying take that repository or directory or file or folder of code and just saying put it on here. Okay, sweet. But what? Yeah, so now you can see that we've pulled down this repository, so I can actually go into that directory. And yeah, so we mentioned branches earlier. So if I run the git branch command, we'll see that there's a main branch. And I can actually make my own branch. I'm not going to push anything up to it, but I could say LBP. And then if I run git branch again, you can see that it's create. Now to actually switch over to that branch, I run the git checkout command. LPP. And then it says I switched to it just to check. We've now moved over to the LPP branch. Yeah, so you can see we've moved over to the LPP branch. I'll just touch text. And then if I run git status, I can see what I've changed. And we'll say, oh, I've added this file. So if I want to like push this up, right? So they're saying this is my local copy. I want to put it where the main one is. So I can run this command called git add, and I can do alex.text. And if I do git status again, I think it'll say, yeah. So now if you notice it's red, it's saying it's, I guess, untracked, but yeah. So I'll make it bigger. Oh, sweet. Yeah, so now you can see it's ready to be pushed up. So if I run the git commit, so these are the basic steps of, we should, I guess they are in the onboarding, but we'll say Alex, right? And then I can do what's called a push after tracking it. So
Put a reference to all this stuff.
Yeah.
Somewhere that you guys can. Fine. But I think in the onboarding, there's taking them. Okay, yeah. And if you guys want, we also send you some better explanations of like what all these commands do. It took me a long time to understand what they really did. I first just learned to copy and paste them. So that might be the easiest way to get started, but we can do that for you guys if you want.
Yeah, and VS Code has really good Git integration, so you'll likely just be doing that through. What? That's true, yeah. But just to keep going with this example, we can actually see that if you remember us calling it a pull request, this is essentially saying, and I'm not going to merge it. I don't even think I can. But it's basically saying open a pull request, which is basically I will just go through and I'll say like somewhere and I'll just say added alex.text and I'll say what it did, what I changed, why I changed it. I'll go through a lot of my reasoning or something. Sometimes you'll include pictures. But yeah, and then you'll get these reviewers over here and they'll look at it and they'll say, okay, this all looks good to me. Once it gets approved, it'll go and get merged into the main code base, which I can't show you the merge, but oh, is there? Oh, there is, yeah. Oh, this is mine. Oh, there is. What, do you just want to do like a yeah, 196, damn. Yeah, so you can see, is this your PR engine? Oh yeah, yeah, look at this. So you can see, this comment is your, like, what you said in the PR, right? This, yeah, so you can see what he said up here. So you can see he basically reasoned through it and says, seems obvious in hindsight, you're returning true if they were disallowed email. I don't know what that means, but yeah, he's essentially describing what he did and then describing how he tested it. That's a typical thing that you can do for these. And then, yeah, like a few people looked at it. What? Oh yeah, you can go to the files changed. And GitHub will actually show you the differences in what was changed. So you change this. Blue one is the new one, right? Yeah, so he changed this to this new one. So this double pipe, I don't know what that means, but it's just an or, isn't it? Yeah, okay. Yeah. He just changed this line to this line and then added these and then got rid of that one. So yeah, you can actually see the changes of the files. If that clears it up. So you can see how these files got merged together through the changes. Well, does that make a little more visual sense to you guys? A little bit? Okay, cool.
As far as the onboarding, everything we over. And also do all of this then.
Yeah.
And your individual projects.
Yeah. Yeah, it's actually pretty simple in Visual Studio Code. Like there's this like source control panel. You can see the files I've changed here. This Vulkan command buffer.h and this Vulkan types.inl. Like those are just the files that I've changed. I could add them and commit them right now. I'm not going to, but and then they would get pushed up. I would create a pull request, merge them in, and then that would be that. Exactly what we just did. It's just no commands. It would just be through the UI. Cool. Any other questions on Git or TypeScript or anything that we covered?
How you guys feeling about this?
Yeah.
Pretty good? Is it confusing? It's tough to just be talked at and learn stuff. That's part of the reason we're also supplementing this with the learning-based project. I imagine a lot of learning will also be done by just trying to figure stuff out. And that's why it's really important you guys fill out those when-to-meets. We can have our first meeting, get coding, and as soon as we can get coding, then we can get you know, we can do pair programming and all that good jazz. Which is super helpful as well.
At any point, you don't have any other questions about any of this, or you want to learn about something and you want to go?
Yep. Yep. Yeah, don't hesitate. I want to help you guys learn. And we'll get better at this too, I promise.
Yeah.
Cool. Well, that's all. Thanks for coming. The
Thanks.
next one is,
Picture.
Picture.
yeah, we're gonna take a quick pic. Next one is next Friday. We're gonna be going over some more stuff. We'll kind of build on this one. So maybe write that program, get a little practice in, you know.
Can you put the X logo on everything? Hell yeah. Where is that?